Okay, chicos, we're going to continue with number 3, which was factoring quadratic expressions. Well, that's the whole thing, but when a doesn't equal plus or minus 1, and that's a in standard form, correct? So we'll do a second example. Go ahead and look over the one that we did yesterday or 2 days ago. Example B. We have 4x squared minus 4x minus 3. And immediately, what I want you to see is, first of all, do I have a GCF between all 3 terms? A GCF is for all, common for all, okay? It's not just common for 2 of them. Do I have one that's common for all? And I don't. And from here, my rules are going to be that I need factors of A times C that add up to B, okay? This is the thing that you have to remember the most. Factors of A times C that add up to B. That's the only thing you really need to remember from here. From there, everything else flows. But if you don't get that first step, then you can't do the whole thing. So A times C is 4 times negative 3, which is negative 12. So I need factors of negative 12 that add up to negative 4. So go ahead and write out the factors, and when you're done, just press play. You should see that the factors that are your winners are 2 and negative 6. You have other factors of negative 12, but the which fulfills the first condition, but not the second, which is that they have to add up to negative 4. So 2 plus negative 6 is negative 4, right? So these are your winners. So from here, what you do with that is that you split this middle term. You're going to split negative 4x into 2x and negative 6x. So I split this into 2x and negative 6x, which adds up to negative 4x. So you're really not changing your expression at all. And you bring down this other stuff too, okay? So you see I've just rewritten my expression, but instead of the middle term being negative 4x, I've split it into these two, because those add up to negative 4 anyway. And now, so that's first the split, and second, you factor by grouping. So you're going to group these 2 terms. These 2 terms and these 2 terms. So you consider these 2 together. What is the GCF of those 2? It's 2x. So you factor out a 2x, left over you have 2x plus 1. Again, if you want to know what you have left over, all you do is divide like that, and that becomes a 1, correct? And then over here, to the right, 6x and 3. They obviously have a 3 in common, but you have to decide whether you want to factor out a negative 3 or a positive 3. Almost always, you're going to factor out a negative. So if I factor out a negative 3, left over I have a 2x plus 1. And you see there that these 2 terms match. If you had factored out a positive 3, this would have been a negative and a negative. So that wouldn't have worked, okay? So almost always, you'll see that you're factoring out a negative here. So now, this is great because at this point, you have these 2 terms in common. And again, this is multiplying. So you're going to factor out a 2x plus 1. So if I factor out a 2x plus 1, and here think of dividing. If I divided 2x plus 1, what do I have left over? A 2x. And over here, I factor out a 2x plus 1. What do I have left over? A minus 3. And that's the factored form. That's the factored form of 4x squared minus 4x minus 3 is equal to that. All right, one more example for 3. And that would be example C. 2x squared minus 7x plus 6. So immediately you see a is not 1. I can't factor out a 2 to make a 1. So immediately you jump into the a times c, adding up to b. So a is 2, c is 6. So I need factors of 12 adding up to -7. You see that in order to multiply to a positive number, meaning 12, in order to multiply to 12, I need factors that are either both positive or both negative. But since I'm adding to a negative number, you'll see that you need to have both of them being negative. And you should quickly notice that your factors are -3 and -4. So from here, that's the next step. You split the middle term. So you have 2x squared minus 3x minus 4x plus 6. Again, look at that. I split this middle term into my winners, which are your factors that are your winners, right? From here, factoring by grouping. So you're grouping, think about, you're almost like building a wall there between the two groups of factors, okay? GCF here is just x. So you have 2x minus 3 left over. Over here, the GCF is 2, and again, you have the choice of 2 or -2. And again, I'm going to go with a negative. And you have 2x minus 3 left over. A question that you may be wondering is, does it matter if I put 3x or 4x first? It does not matter. Okay, it does not matter, and I actually encourage you to do it the other way that I'm doing it, meaning putting 4x before 3x. You'll get the same answer, okay? It doesn't matter which one you place first. And from here, I realized that 2x minus 3 is common to both. So I can go ahead and factor out a 2x minus 3. And left over here is x minus 2x. And that is your factored form. And we're done. Okay, so that's it for those examples. If you want to keep practicing, there's more in the book and in the homework. But go ahead also, you can practice by switching the order of these two. Okay, example, now we're going to number 4. Oops. Number 4 is my second favorite type of factoring, and it's called a perfect square trinomial. Now, let's see if any of you caught this. A perfect square trinomial. What are those initials? PST. So yes, this is true. This is where PST actually originated 4 years ago. Wow, 4 years ago, yep. I said, okay, let's call this a PST, and then they joke with the whole RPST. So let's just think PST for this as perfect square trinomial, not as we think of PST. So a perfect square trinomial. I'm going to give you an example first so you guys can learn how to recognize what a perfect square trinomial is. I'm going to give you a really, really basic one that you can factor already, that you already know how to factor. Okay, so x squared minus 18x plus 81. You're happy because a is 1, and so you're looking for factors of 81 that add up to -18. And you should quickly realize that these are -9 and -9. Now, since these two are the same, and it's just multiplying the same thing twice, I can re-express this as x minus 9 squared, which is what I always tell you, right? You always go from this direction, and a lot of you want to do x squared minus 9 squared, and I say, no. What is x minus 9 squared? It's x minus 9 times x minus 9. So I can express this trinomial, again, this is a trinomial, I can express it in factored form as a square. So we call that a perfect square trinomial. Why? Because it's a trinomial, again, 3 terms that can be expressed in factored form as a square. What are the conditions to be a trinomial? If we look over here at our trinomial, the first condition is that the 2 outer terms have to be squares. So x squared is a squared, right? It's x times x. And 81 is a square, it's 9 squared. The second condition is that the middle term has to be plus or minus, it doesn't matter the sign, 2 times the square root of this term, which is x, and the square root of that one, which is 9. Is that 2 times x times 9? Is that 18x? Yeah, this ends up being 18x. So that condition holds. Again, my two conditions are that the outer terms have to be squares, which they are, and the middle term has to be 2 times the square root of this one, which is x, times the square root of that one, which is 9. 2 times 9 is 18 times x, 18x. So, to formalize that, a perfect square trinomial is one in which the outer terms are squared, so we're actually going to call these a squared and b squared. And this is always going to be positive b squared, right? Because you're always going to multiply the same term times itself, so it's going to be positive positive or negative negative. And I'm going to write this down here too. And it's going to be that the middle term is 2 times a times b. So a is just the square root of a squared, and b is just the square root of b squared. And this can either be positive or negative. And this is factored into a plus b squared, or in this case, a minus b squared. The sign is dictated by this. Okay? Now, if we look at our example here, we saw that a was x, all right? B was 9, because that's square root of 81, and it was minus because of that minus sign. And voila. Now, in this one, you don't have to do a PST because you already know how to factor that. But a PST is very, very useful when a is not 1. Okay, so let's check one of those out. So, I have 4x squared minus 20x plus 25. So, a is not 1. They have no GCF. And I could start doing a times c, so factors of 100 that add up to negative 20. And immediately you start seeing that the numbers start getting a lot bigger, right? That's doable, okay? That's doable. You can for sure do that. But it's going to be really, really important for you guys to recognize when you have a PST, because it's going to save you so much time and so many mistakes. So there's going to be really 2 types of factoring that you're going to have to recognize in order for you to just save time. This is one of them. Okay, so again, the first thing you want to look at is, are my outer terms squares? So you see here that is a square and that is a square. So once I recognize that, I immediately start writing right under it what the square root of that would be. So here it would be 2x and here 5. And that's the first step, okay? The first step is to check, are my outer terms squares? And if that is such, right, for us right now we can say check. If that is such, then you move on to the second criteria. The second criteria is my middle term 2 times a and b. Again, a and b, this is a and that is b, right? Is my middle term two times those? So I check it. I say, okay, is it 2 times that? Let's see, 2 times 10x, 20x. Beautiful, it is. So you say, okay, check, great. And now you just prove that these are the 2 recipes. 1 plus 2 are the 2 conditions to have a PST. So I do have a PST. And a PST, just like for us, is good news. A PST is great news for factoring too, because it saves so much time if you can recognize it as such. Okay, so again, are these squares? Yes. Is the middle term 2 times the square root of those? Then all you do from here, chicos, all you do is say, okay, what is A? A was 2x. What is B? B is 5. What's the middle term here? Sorry, what's the middle sign? Negative. And that's it. And that is the factored form of 4x squared minus 20x plus 25. So much easier than doing A times C adding up to B. Again, this only works if if 1 and 2 hold. Okay, so just check that out. If it does hold, then you have a PST. Okay, so one last example, C. Let's see, let me find a tougher one for you. It's not too bad. 125a squared minus 120a plus 144. So remember when I kept bugging you about learning the squares and how important that was? It's still important, and you see how it's still serving you. Immediately when you have a trinomial, you want to check, do I have a PST? So, do I have a PST? Conditions. Number 1, is this a square? Yes, it is. Is this a square? Yes, it is. If that is such, then under it, I want you to right away write what the square root of that would be, because that becomes a and b. Here it's 5a, and here it's 12. So that's the first condition, correct? The second condition is my middle term 2 times a times b. So 2 times 5a times 12. 5a times 12 is 60a. It's 120a. And you realize that, yes, my two conditions held, which is these are squares, and this is 2 times those. And all you do at this point is factor. A is 5a, b is 12. The sign in the middle would be negative because of that, and it's squared. And that, my friends, is a PST, a perfect square trinomial. Number 5. This is my favorite type of factoring. It's called a difference of squares. So a difference of squares is exactly what it sounds like. It's 2 squares separated by a minus sign. Difference is minus, correct? So a difference of squares is going to be 2 squares, so we can call them a squared and b squared, separated by a minus sign. For example, let's say we have the following. Let's work in the other. I'm going to show you in the other direction first. So let's say that you have the following already in factored form, okay? Again, I haven't defined difference of squares with how to factor it yet, but you'll see that in a second. So let's say I have the following. It's already in factored form, but I want to see where it came from, right? I want to see what was this in standard form. This is factored form. So I distribute out. I get x squared plus 3x minus 3x minus 9. You see immediately that your middle terms cancel out, and you're left with x squared minus 9. X squared minus 9 is a difference of squares. Why is it a difference of squares? Because it is 2 squares. Again, this is x and that's 3, right? Those are the square roots separated by a minus sign. So anytime you have that, 2 squares separated by a minus sign, which is what I had drawn up here, then the factored form of that is always going to be a plus b and a minus b. As we saw down here in example A, right? It's going to be x minus 3, x plus 3. X is the square root of my first term, 3 is the square root of my second term, and those are separated by a minus sign here. So you do x minus 3 and x plus 3. Why the plus and why the minus? Why the alternating signs? Because that is the only way in which the middle terms cancel out. And by having plus and minus, that's how you get the difference of squares. That's how you get that minus sign at the end. So the conditions here are 2. You need to have 2 squares separated by a minus sign. So, for example, let's do one here. 25x squared minus 16. Do I have 2 squares? First of all, you see that you only have 2 terms. You're missing the bx term, right? So if you're ever missing the bx term, then you have 2 options. You can either factor out a GCF or do difference of squares if that is there, if that exists. So here you say, do I have 2 squares? Yes. This is going to be 5x. This is going to be 4. So this is the same pattern as I was doing with the PST, that under it I would write what the square root is. Why? Because then that helps me factor so quickly. So I do have 2 squares, and now do I have a difference, right? Are they separated by a minus sign? They are. So then this is cake. All I do is 5x plus 4, 5x minus 4. Now, if you want to check, you distribute out. So this becomes 25x squared minus 20x plus 20x minus 16. Ciao, and I'm left with 25x minus 16, which holds. difference of squares. Cake, 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 cake. So awesome, so easy to recognize, and so useful for math beyond just algebra 2. Like, for sure, I'm doing this in pre-cal so much, difference of squares. Okay, so make sure that you guys are really solid on difference of squares. All right, let's give you a quick one for you guys to try. Let's see, 121 y squared minus 100. Try that real quick. So you see that I have two squares separated by a minus sign. This is going to be 11y squared. This is 10 squared, so in factored form it's 11y minus 10, 11y plus 10. Now, some of you may be wondering, what happens if I had had the following, 121y squared plus 100? That's not factorable using real numbers. It is doing imaginary, okay? But we won't be doing that yet, so this is not factorable with real numbers because of the plus sign, okay? So just make sure that that it is a difference of squares, not an addition of squares. I'm sorry. Now, something that you might see is the following. This is difference of squares for sure, and this factors into 8t minus 4, 8t plus 4. You guys should be recognizing this right away. Now, if I'm told to factor completely, what that means is that factor completely, that there are no common factors left. Factors left. Now, if you see here, both of these still have something in common. That's what I mean by common factors, okay? They both have 4 in common. So the way to ensure that this doesn't happen is that you always factor out a GCF first. So if I go back here to my original, if I factor out before I even do difference of squares, even though you recognize that's difference of squares, that's awesome. Before I even do that, what do they have in common? They both are factors of 16, right? 16 times 4 is 64. How do you know that? Because you know that 4 cubed is 64. 4 times 4, 16, times another 4, 64. So if I factor out a 16 first, I'm left with 4t squared minus 1. And you're actually in luck still because 1 is also a square. 4t squared is also a square. So you still have difference of squares. The square here is 2t, this is just 1. So you would factor this completely factored as 16, don't forget that leading 16, times 2t plus 1, 2t minus 1, okay? So once you factor out the 16, then you just treat this as a normal difference of squares, which is 2t plus 1, 2t minus 1. So this would be fully factored. Why is it fully factored? You see that these have nothing in common anymore, other than 1. So nothing in common other than 1. That's fully factored. So this is going to be your hardest example for difference of squares. So D, 81 x to the power of 4 minus 256 y to the power of 4. So immediately you realize two things. Number one, you have a second variable. That's fine. And number two, they're to the power of 4. Now, we know that 4 is a square also. We know that. It's the easiest square that we know. And you also know that x squared is x to the power of 4, right? You just multiply the exponents. So you know that you can express x to the power of 4 as a square, which is x squared squared. Now, we know that 81, well, first of all, do I have a GCF? I don't. 256 divided by 81 is not divisible. 256 divided by 9 is not divisible either. So I jump straight into difference of squares. I know that the square root of this one would be 9x squared, and the square root of that would be 16y squared. So 16 is not one that you guys know right off the bat, but you should recognize 256 moving forward, okay, as 16 squared. At least know that it's a square, and then you can start dividing or multiplying to see which what the square root would be, okay? You know it's not going to be 15, okay? Maybe some of you might thought 14. Just try it out, but just know 256 is a square. So I rewrite this as 9x squared plus 16y squared times 9x squared minus 16y squared, right? That's a definition of a difference of squares. Close the parentheses. Okay, so now we recognize that these are still squares, right? But that's only the first condition. The second condition is that it has to be separated by a minus sign. That one won't work for difference of squares. That one will. So if I go back here, this one's going to remain as just 9x squared plus 16y squared. But over here I can go further. I know that the square root here would be 3x, here it would be 4y. So I can rewrite this second factor as 3x plus 4y and 3x minus 4y. Does it matter which factor I write first, this one or that one? No. Okay. Multiplication commutes, order doesn't matter. And that, my friends, is fully factored. Again, fully factored is they have nothing left in common. No factors left in common. Here, no factors left in common. Here, no factors. Here, no factors. So I can rewrite 81 x to the power of 4 minus 256 y to the power of 4 as this in factored form. And that is fully factored, okay, guys? And we're done. We're done with chapter 4, section 4. You can go ahead and do Math Excel now. Talk to each other if you have any questions. Ask Mr. Elizarbe. Email me, okay? Until the next one.